Hello guys, today's lesson is on right triangles. At the end of the lesson, you should be able to find the missing side length of a right triangle. Recall back in geometry that the Pythagorean theorem is used to find the missing side length of a right triangle. The Pythagorean theorem says that a squared, which is a leg, plus b squared, which is another leg, is equal to c squared, which is the hypotenuse. So if we look at this diagram of a right triangle here, we have that the two legs of the triangle, which are the sides that make up the 90-degree angle, are identified as A and B, and the hypotenuse, which is the side that's always opposite the right angle, is identified as C. And then we could use this handy dandy theorem here to find a missing side. But the case is that you have to have two of the sides of the triangle known in order to find the third side. In this example here that is given, we can see that here's the right angle of the triangle, so we know it's a right triangle. The two sides that make up the right triangle are labeled as 14 and 10. These are the two legs of the triangle. And then the side that is opposite the right angle is labeled as x, so that would be the hypotenuse. So if we use the Pythagorean theorem, a squared plus b squared equals c squared, and we substitute in values for a, b, and c, we would have the following equation, that 14 squared plus 10 squared is equal to x squared. Using a calculator, we could find the sum of 14 squared and 10 squared, and it gives us 296. So 296 is equal to x squared. In order to find the value of x, we would have to take the square root of both sides. So x is equal to the square root of 296. We want to leave our answer in simplest radical form. So to do that, we have to go back to all of those nice little perfect squares that we have in our memory bank and try to think of the largest perfect square number that can divide evenly into 296. And 4 is the largest perfect square that can divide into 296. 4 times 74 gives us 296. So x would be equal to the square root of 4 times the square root of 74. Well, the square root of 4 is 2, and in the square root of 74, well, we'll just leave that as the square root of 74 because it's irrational. So x is equal to 2 times the square root of 74. Take a moment to complete exercise 1 and 2 on your worksheet. Okay, so we have a couple of special right triangles, and one of the special right triangles is the 45, 45, 90-degree right triangle. If we look at this right triangle here, we see that the right angle is labeled here, and that each of these angles measure 45 degrees. Going back to a little bit of our geometry work, recall that if the base angles of a triangle measures the same thing, then the triangle is an isosceles triangle, and the sides of the triangle measure exactly the same. So we'll find that the legs of the right triangle each measure x. So let's say if this measurement is 10, then this guy over here would also be 10. If you were to plug it into the Pythagorean theorem, you would find that the hypotenuse of a 45 degree right triangle is going to be equal to x times the square root of 2. So let's apply that to this example. So if we look at the example, we have the right triangle. We have that this angle here is our 90-degree angle. And we have that this angle here is 45 degrees. In a triangle, any triangle, whether it's a right triangle, any other type of triangle, a scalene triangle, an equilateral triangle, the sum of the three interior angles adds up to 180 degrees. So if this angle is 90 degrees and this angle here is 45 degrees, it would mean that this angle here has to also be 45 degrees. So now we have that special 45 degree right triangle. So if this side measures 2 radical 10, then this side has to also measure 2 radical 10. So now we have that x is equal to 2 radical 10. The hypotenuse of a 45 degree right triangle is equal to x times the square root of 2. So here I wrote the equation y, which is what the hypotenuse is labeled as, is equal to x times the square root of 2. Well, we know that x is equal to 2 times radical 10. So there we could replace x with 2 radical 10 and we'll have the new expression 2 radical 10 times radical 2. When we multiply radicals, we multiply the stuff underneath the radical symbol. So 10 times 2 gives us 20. So this becomes 2 times radical 20. Again, we want to leave our answer in simplest radical form. And in simplest radical form, 20, the largest perfect square that can divide into 20 is 4. So this becomes 2 times radical 4 times radical 5, because 4 times 5 gives us 20. Radical 4 is equal to 2. So this becomes 2 times 2, which is 4, times our remaining radical 5. Now take a moment and go to the worksheet and complete questions 3, 4, and 5. Okay, next up is the 30-60 degree right triangle. Okay, so if we look at this triangle here, it's a right triangle because we have the right angle is labeled here. This angle over here measures 30 degrees and this angle over here measures 60 degrees. It's important to pay attention to who measures 30 and who measures 60 because the side that's opposite the 30-degree angle is the shorter leg, and the side that's opposite the 60-degree angle is the longer leg. The shorter leg of a 30, 60, 90 triangle measures x. The longer leg measures x times radical 3. The hypotenuse, which is always opposite the right angle, measures 2 times x. So let's apply that to this example. So if we look at this right triangle here, we see that here's our right angle, here's our 30-degree angle. And if this angle measures 30 degrees, then this angle has to measure 60 degrees. Opposite the 30-degree angle is the shorter leg, which is labeled as y. And opposite the 60-degree angle is the longer leg, which is labeled as x. The hypotenuse, opposite the right angle, measures 14 times radical 3. If I wanted to find the value of y, which would be the shorter leg, I know that the hypotenuse is equal to 2 times the shorter leg. So 14 radical 3 is going to be equal to 2 times the shorter leg, which in this case measured is y. Solving for y, I would divide both sides by 2, and I get that y is equal to 14 times radical 3 divided by 2. 14 divided by 2 gives me 7. So my final answer for y is 7 radical 3. Next, to figure out the longer leg of the triangle, the longer leg of the triangle is equal to the shorter leg times radical 3. So the shorter leg measures 7 radical 3. So that means that x is going to be equal to 7 radical 3 times radical 3. Well, radical 3 times radical 3 is going to give me radical 9. Radical 9 is equal to 3, so 7 times 3 gives me 21. So the longer side of the triangle would measure 21. Take a moment and finish up the other 3 questions, 6, 7, and 8 on your worksheet.